All right, the first thing we need to look at when we're dealing with ionic compounds and we're looking at writing the formulas for those compounds, we need to understand that ions have charges. And so for the formulas, we have to balance those charges because ionic compounds are neutral. The positive charges will equal the negative charges. Now, one way that we can go about balancing compounds is like this. So let's say I have aluminum sulfide. All right. And what I'm going to do is I'm going to just look on my pink ionic charges chart that you guys have at your desk, or they were at your desk when you came in. And the positive ions are at the top, the negative ions are at the bottom. And so what I'm going to do is I'm going to look for aluminum on the positive ions uh, side of the chart. I find aluminum and I see that the symbol is Al and the ion has a charge of 3 plus. All right. Then I go and I do the same thing for sulfide on the bottom. I find that sulfide, the symbol is S and the charge is 2 negative. So if I put one aluminum, okay, with one sulfide, the overall compound will not have a charge, will not be neutral. Okay, it will have a charge of positive 1. And so it is not going to come together in a 1-to-1 ratio. All right, so what I need to do is I am going to have to do a little bit of math, but it's not that difficult. And if I think about it, when I'm looking at 3 and 2, and if I'm saying this correctly, I look at something called the least common multiple. And between 3 and 2, it is 6. So if I can get aluminum to 6, and if I can get sulfur to 6, then I should be okay. Now, how am I going to do that? Well, aluminum already, we have one of them and it's 3 plus. If I add another aluminum that has a 3 plus charge, now on my positive side is 6. If I go with sulfur, and I add another sulfur, that would give me 4 negative. This gives me 2 negative, and now I have 6 negative. And if I take 6 positive and 6 negative, add them together, I get 0. So this is going to be neutral. To write out the formula, I want to show how many ALs and how many S's I had to get to balance this out. So AL, there's 2. Oh, I'm sorry. There's 2 of them. So I get the subscript 2, and S, there's 3 of them, and it gets the subscript 3. Okay, so that is one way that you can write out your formula with balancing the charges. The other way is called the crisscross method. Okay, the crisscross method. So I'm going to use aluminum sulfide. So Al 3 plus, S 2 negative. Okay, I'm going to rewrite my symbols, Al and S. And so what the crisscross method is telling me is that I can take my the numbers from my oxidation numbers, and they're going to cross over and become subscripts for the other elements. So here, the 3 from aluminum is going to come here and become the subscript for the sulfur. Okay, and then the 2 from the sulfide is going to come over here to the aluminum. All right, and I'm just going to bring it back down here where I actually put them together without the space, Al2, S3. I want to check to make sure that I do not need to simplify my formula. You can see the Al, the 2, and the 3 cannot be simplified any further, so everything's good to go. And so either method works well. You'll get the final answer, so you can use it where you're adding ions until you get to where, when you add them together, it's going to be 0. Or you can use the crisscross method, where you just take the number from the sulfur becomes the subscript for aluminum. The number from aluminum becomes the subscript for sulfur. Now remember, or pay attention, I did not bring the charges down, I just brought the numbers down. Okay, that's balancing charges.